Today we take a look at section 4.6 combinations, and just before I begin, there is a section 4.7, but there won't be a video lesson of it, simply because section 4.7 just does an overview of all of the concepts. So I would probably recommend you read the PDF notes, try a few of the questions, and then you will be done chapter 4. Now, today when we do combinations, in the title and the PDF notes, right after combinations, it says order does not matter. When you are doing a permutation, which we've already looked at in depth, which is using the NPR button on your calculator and also the factorial, order is really the key thing. What you're trying to do is figure out in how many different ways can you order things. We talked about running an Olympic race. You could think of these three markers and how many different ways could I arrange their order first, second, and third. That is a permutation when order is really important. When you are doing a combination, you're not actually looking at order. What you're simply trying to say is how many groupings can be taken from a bigger group. And so you're going to have to put your imagination caps on. You're looking at this remotely. I want you to imagine you're in a classroom. And for our very first example, what I want you to imagine is you're in a math class, my math class, with 25 students. And what I'm going to do is I'm going to pick 5 students to come up to the front of the class and to sing a very simple song. Now, it doesn't matter whether you like singing or you don't like singing. If I was going to say in how many different ways could I choose 5 out of the 25 students, order does not matter. We're just simply trying to say in how many different ways can I pick 5? How many groups of 5 can I pick to sing in front of the class? So you can see the question again in the PDF notes. The solution, what it does, because order does not matter, we're just looking for how many combinations of 5 students can we pick out of the total of 25. This is where we use the NCR button, and it does all the work for us. The N stands for the total number of students. The R is how many we're going to pick. And here's what it says. There's a large number. There would be 53,130 different groups of 5 students I could pick. And again, it'd be way easier if we were face to face and we actually had 25 students around us and I could do examples. I could say we could pick Joe, John, Frank, Sally, and Susie. Or no, wait, we could pick Joe, John, Frank, Courtney, and Abby. There's all different groups of 5 that we could pick to come up and sing. Order doesn't matter. That's what a combination essentially does. Now, number 2 in your notes, the formula for combinations. I won't even put this down in color because if you have this button on your calculator, this is insignificant. This formula would only be useful if you did not have the combination button on your calculator, but most do. This is how you could calculate it just using a factorial. Believe it or not, the odd calculator does not have it. Now here is where once you see the idea and you really buy into order does not matter, the questions become quite easy, and the NCR button on your calculator is phenomenal. So here's a different scenario. Let's say there was 9 students in my classroom at lunch hour, and it was getting nice outside, and so I said, hey, I want to take 4 of you to 7-Eleven and let's get our first Slurpee of spring. I can only take 4 because I have myself and 4 more seatbelts. So it doesn't matter what order you're in. Order doesn't matter. You just want to be one of the 4 out of 9 going to 7-Eleven to get a Slurpee. If I wanted to know in how many different ways could I pick 4 out of the 9 people, well then again, it is a combination. How many combinations of 4 people can go to 7-Eleven with me? The N again stands for the total. So in the PDF notes, I said there was 9 students, and then I'm going to pick 4 of them. So how many groups, how many combinations of 4 out of the total of 9 can we pick? A much, much smaller number than before. It should make sense that if you're picking 5 out of 25, and there's all different ways you can pick 5 out of the total of 25, you'd have a massive number of ways you could pick a group of 5 out of a total of 25. Here, you have a much smaller way. There's only so many ways you can pick 4 out of 9. Now, what we are going to move to for the 4th example is a very, very common thing in combinations and also probability. We're almost done chapter 4. Chapter 5 probability starts to use all of these concepts from chapter 4 and chapter 3. One of the best learning tools for probability, and now for the end of our chapter 4, is using cards. Okay, they are very, very useful to teach different areas of combinations, especially, and then probability. For example, I'll start it and then move on. If I had my standard deck of cards, which has 52 cards in it, what is the probability that this is an ace? Well, that's one of the things that we'll take a look at. We'll get a formal definition. Now, here is what we can do, and it really does show that order does not matter. Let's say I said, let's pick a 5-card hand. This would be like a classic poker thing, not like what you see on TV. In this 5-card hand, if I wanted to know, well, how many different 5-card hands are there? Here is one. I just randomly picked these, but if I even just took one card away and took a different one in, this is a different 5-card hand. Well, then I could replace this one, put this one in, and then if I said to you, how many different 5-card hands are there? If you did not understand a combination and how to use it, this would be a frustrating question. You'd be here till the next century trying to figure out all the different combinations, and you'd probably drive yourself crazy. This is where the beauty of the combination comes in. To make this calculation, what we simply do is we say, there are 52 cards in a standard deck. We will never not use anything but a standard deck. Some of you might be like, well, is there such a thing as a non-standard deck? Yep, you can actually buy decks of cards that only have, say, 32 cards in them. If anyone plays Kaiser, they would understand that. But we'll always just go with a standard deck. So what we're trying to do is make the calculation 52C5. How many different ways can you pick 5 out of the 52? And it is big. This is in the millions. It's 2,598,960 when you type it in. There is a lot of different ways. And now you guys, the order doesn't matter really, I hope, makes sense. When we take these 5 cards, this is your 5-card hand. Doesn't matter what card game you're playing. If I take this jack and put it in the middle, it's still the exact same hand. Order does not matter. That is the combination. We're just trying to say how many groups of 5 can we take out of the total of 52. Now, for the end of your day, what we're going to do is just go somewhere different where now we see immediately, okay, the combination is a really powerful tool. You haven't even studied probability yet, but you know this is going to help you out just with that little introduction. But what we need to do is start to introduce a few of the key words in probability. So number 5, the end of your notes and then the end of the chapter, this is the scenario that I set up. Let's say there were 17 total students in a classroom, and 10 of them were girls. This is again in the PDF notes. 7 were guys. And what we are going to do is we're going to pick a group of 5 for whatever, whether you're singing, going for Slurpees, you name it, you can do it. What if we just started this way? Letter A. In how many different ways can we just pick 5 out of these 17 people? There are no conditions at all. Well, that is a game where we use the combination. We're just trying to say how many groups of 5 could we take. There's 17 total students, and we're going to take 5 of them. We type into our calculator 17C5, and we see there are 6,188 different ways you can pick 5 out of this total. You can put a scenario into your head. You could think of, well, there's going to be 5 people chosen to win an award. There's going to be 5 people chosen to make it on a badminton team. Like whatever scenario you want to put into your head, that is essentially what we're doing. Now, letter B, something very, very important happens. This is the first time you've seen it, and this will extend into probability as well. What if we narrowed it down? What if we were going to choose 5? We'll stick to just 5 people being chosen, but then there was a stipulation. What we must have is 3 girls and 2 guys. And I want you to imagine again the 7 guys. There could be Joe, John, Frank, and then 4 other guys. We're going to pick 2 out of the 7. We're going to pick 3 out of the 10. Now, we still use a combination, but something different is going to happen. And just watch as it unfolds, and then a very important thing will happen in the middle. And I'll actually use red for the first and only time. When we are picking 3 girls, what we actually do is we just start by saying, okay, there's 10 total girls. How many different ways can I pick 3 out of the 10? We have to treat the guys separate because now we have some conditions. In the first one, there was no conditions. Over here, it is 7C2. How many different ways can we pick 2 out of the total of 7? Now, this is the key moment. Okay? What you will see in the PDF notes is the word and it is underlined. And you're going to do this as a memorization. It'll make more and more sense as we go through probability in chapter 5. When you see the word and, what we actually do is we multiply, okay? Because it means this is going to happen 3 out of 10 girls, and we're going to pick 2 guys. And what we simply do is we get each value and then multiply for a finish. If you just type 10C3 into your calculator, it comes out to be 120. If you type in 7C2, it comes out to be 21. And by multiplying, we get 2520. Okay, because both things are going to happen. We multiply to get the total number of combinations that we can have. Once you see that, the next question, letter C, this one actually you start to get into a good groove and you're feeling probably pretty good about yourself. This one says, in how many different ways can we get 4 girls and 1 guy? So you get into a good flow. 10C4, how many ways can we take 4 girls out of 10? How many combinations? And then we multiply by 7C1. How many different ways can we pick 1? So 10C4, we definitely type into our calculator, we get 210. If you really think hard, this is going to make sense. Typing 7C1 into your calculator just gives us 7, because you're only picking 1. Okay, so there's 7 different ways, and then we multiply for a finish to figure out the total number of ways we could get this to unfold. Now, I'm going to slide in letter D right over here. Letter D is really quite nice. It might trick you right at the start, but then you're like, oh, hey, that's even easier. What if we just wanted all 5 to be girls? We would write 10C5, nothing else. No guys are going to be chosen. They're out of the picture. And then we'd type in 10C5 to see 252. Now, the end of our day, the end of the lesson, goes to the largest one. And this is how we end the whole chapter. This one right here has a crazy condition. It says how many groups are possible if there must be 3 guys, and even the PDF notes have something a little bit wrong. I apologize. It's supposed to say at least 3 guys. Okay, it could have been just my problem on the board or the person who took these notes down who I photocopied them from. So this one right here, you might be like, no, this isn't hard. There's no problems. If there's supposed to be at least 3 guys, that means 2 girls. So we would have 10C2, that's 2 out of 10 girls. We would have 7C3, and we would multiply them. And we would dust our hands off thinking this is easy, but no, it's not. What I want you to do is just watch what else there is. There could be other things that happen if the notes were written correctly. Again, it should say the words at least. This could be what happens as well. There could be 4 guys and 1 girl. That's at least 3 guys. It's more. It's 4. And then it could also be 10C0. That means no girls. And 7C5. That means all guys. Now, here's what's going to happen. We already introduced that you multiply when you have 2 things. This is going to happen and this is. Each one separately could be calculated. 10C0, it will be just a 1. Okay, so it will not factor in. You don't even need that there, just like we did in the previous example. Now here is where then the grand finale comes in. And I'm going to just leave it up to you guys to type. What would you do with each of these answers? Because this first scenario could happen, or this second scenario could happen, or this third. The word or in probability, you add. So the word and you multiply. The word or will tell your brain to add these 3 answers together.